Day 28, Ionic Compounds with Polyatomic Ions, Part 3. Today we're going to work with polyatomic ions that have a charge of -1 and -3, and we're going to combine those with +2 ions from our periodic table of ions. So let's get going. We're going to start the day off with calcium. Calcium is a +2 ion, and we're going to combine that with nitrate, which is a -1 ion. So +2 -1, we need another nitrate ion in order to get to 0. So we're going to have calcium, we have one of those, and we're going to have 2 of these nitrate ions, 2 of them. And now we don't use the subscript 1, so we're going to have calcium NO3, CaNO3, 2. There we go. That's how it's done. We could also say calcium, which is a +2, nitrate NO3, which is a -1, and then we can play that crisscross game, go like this, and then we'll get calcium and then NO3 2, calcium 1, nitrate 2, and you can see we get the same thing. Now what I also want you to do is to make sure that you know how to set this up correctly where you can get the charge of the ion. What I mean by that is on your periodic table of ions, you know that calcium is a +2. There's only one in the box. And we have one of those calcium, so +2 times 1 gives me a +2. And now +2 plus some number has to equal 0 because that's the whole goal. Remember, we want to get to 0. So that number is going to be a -2. Nitrate, this whole thing in parentheses, I have 2 of them, so some number times 2 gives me a -2, and that number has to be a -1. I'm going to write out a formula, and I'm going to call it calcium. Now arsenate, now that's in our polyatomic ion table, so let's use calcium arsenite. Arsenite. It's a little bit different. Arsenate, right down here, that is ASO4. And if you remember how I taught you to name polyatomic ions, the ite has 1 less oxygen than the 8. Now I'm just going to go ahead and give you the formula. It's going to be Ca3ASO3 in parentheses 2. I'm just going to go ahead and give you the formula. Now the question is, you know that arsenate is a -3 ion, but what is the charge of arsenite? You might suspect that it could be a -3, but how are you going to find out for sure? Well, you're going to go back and use what we did over here. Get to 0. And the way we did it is the same method that's right here in front of us. Remember, calcium is a +2. +2 times 3 is a +6. +6 plus some number has to equal 0, and that's got to be a -6. So this arsenite, some number times 2 gives me a -6, and that number can only be a -3. And so you know that arsenite has a -3 charge. You know that that polyatomic ion is a -3. So what I've shown you is a method to get the polyatomic ion charge even if you've never seen the polyatomic ion before. It's a systematic way of problem solving. So I'm hoping you'll find that to be useful. Once you know that arsenate is ASO4, arsenite is 1 less oxygen, so you should have known to write ASO3. So this ASO4 is arsenate. Let's just go back. ASO4 right here. ASO4, that is a -3 charge. That's called arsenate. And then what is ASO3? -3 charge, that's called arsenite. And ASO2 with a -3 charge, hypoarsenite. And what if I had ASO5? ASO5 and asked you to name what that polyatomic ion is? That would be called perarsenate. So don't forget the tools I taught you from earlier sessions because they will help you name the compounds. The naming of polyatomic ions is very systematic, and you need to know the polyatomic ion name in order to name the compound. So let's move on. In this first set, I'm just taking a +2 ion from your periodic table of ions. Calcium, magnesium, beryllium, zinc. I'm just taking a +2 ion. And I'm going to combine that with a -1 polyatomic ion. And there's a whole bunch on that list of polyatomic ions that I told you to know. So we have nitrate, nitrite, we have a chlorate, and a chlorite, and a hypochlorite. Notice that the chlorate is ClO3, the chlorite, one less oxygen, the ClO2, the hypochlorite, ClO. What if we had zinc and the name of the compound was called zinc perchlorate? How would you write out zinc perchlorate? Zinc is Zn with a +2 charge, and I said perchlorate. Perchlorate is ClO4, and it has a charge of -1. And so we would write out zinc perchlorate as Zn parentheses ClO4 2. Zinc perchlorate. So we have perchlorate right here, ClO4, chlorate, ClO3, chlorite, ClO2, and hypochlorite, ClO. All of them have a charge of -1. So now let's work with -3 polyatomic ions. And we're going to work with calcium and phosphate. Calcium is a +2. Phosphate, PO4, this whole thing has a charge of -3. We have to get to 0. So if I add another one of the calciums, we can see that, hey, this is a +4, and then we have a -3. So if I have another one of these PO4s, and now I have 2 of the polyatomic ions, so I have a total of -6. So I'm going to need another one of these calciums to give me a +2. Okay, so then we have 1, 2, 3 calciums, and we're going to have 1, 2 of the phosphates, PO4, Ca3PO4 2. And we could also go this way. Calcium is a +2, phosphate PO4, which is a -3. Play that crisscross game, Ca3 parentheses PO4, and then put a 2 there. Calcium phosphate. Borate is another polyatomic ion with a -3 charge. So in that case, we'd have calcium borate. Just picking another +2 charge like magnesium, beryllium, or zinc, and combining it with arsenate or phosphate or some other, you could use arsenite or hypoarsenite or perarsenate. It doesn't matter. What I'm hoping to achieve is your ability to expand your vocabulary. What I'm trying to make certain you know how to do is to take a charged ion and a polyatomic ion, combine them together, write the correct chemical formula, and then name it correctly. Now, a big part of that naming is, do you know the name of the ion? Because if you don't know the name of the ion, you can't possibly write it out. Now, just to recap, like yesterday, if you remember, I'm only using the positive ions where there's only one in the box. We can do this when there's more than one in the box. And so let me give you an example. And so let's say I asked you to tell me the formula for, let's use copper 2, let's just say copper 2 phosphate. Copper 2 phosphate. Okay, well, copper 2 is Cu with a +2. Phosphate is PO4 with a -3 charge. I'm just going to play that crisscross game, and I get Cu3 PO4 parentheses 2. And the name of this compound is going to be copper 2 because I used a copper 2 ion, copper 2 phosphate. That's how it's named. When there's more than one in the box, all we do differently is add that Roman numeral to the compound. Okay, I hope this helped you. Have a great day.